Okay, 2012, question 2. The equation of two circles are C1 x squared plus y squared minus 6x minus 10y plus 12 equals 0. And C2 x squared plus y squared minus 2x minus 2y minus 43 equals 0. And part A of question 2, we're asked to write down the center and radius of two things of each circle, so actually four things. Okay. Part B, we have to prove that the circles are touching. Now, every time I see a circle in that form, we say, what's G, what's F, what's C. For G and F, I just have the coefficient of x, which in this case is minus 3. For F, I have the coefficient of y, minus 5. And for C, it's the constant. So the same over here, we get minus 1, and minus 43. Using a formula from the log tables, or basically G squared plus F squared plus C, I get minus C. I get minus 3 squared plus minus 5 squared minus 29. And R is equal to root of, now the minus 1 squared plus minus 1 squared, now carefully here, it's negative 43. So that gives me R here on the C1 of 9 plus 25 minus 29. And R in C2 will be 1 plus 1 plus 43. So if I come into the center then, I have center C1, you get the minus G minus F, so you change the signs of G and F to get 3, 5. Okay, and the radius length then is simply this worked out, which happens to be root 5. For C2, changing the signs of G and F, I get 1, 1. And for the radius, it turns out to be root 45, or if your calculator do this, it's 3 root 5. Now for the question 2b part, to prove that the circles are touching, it's enough to show that if the distance between the centers and is equal to the difference of the radii, then you have touching circles. So distance between centers first. Okay, so I'll do x1 and y1 up here, x2, y2. Okay, and that gives us okay, 3 minus 1 squared, 5 minus 1 squared, gives distance of root 2 squared plus 4 squared, which is root 20, or 2 root 5. Okay, difference of radii, so take the first radius, the bigger one will be 3 root 5, subtract root 5, okay, that's C2, C1, you get 2 root 5, so they're touching. Okay, so in part C we're asked to verify that that point is the point they have in common, 4, 7. And in part D, you have to find the equation of the common tangent. Okay, so when you're asked to verify that something is on a circle, we have to put the left hand side of the circle when I sub in must be equal to the right hand side. Okay, for C1, I have x squared plus y squared minus 6x minus 10y plus 29 equals 0. Okay, for C2 then, go down a bit and we have x squared plus y squared minus 2x minus 2y minus 43 equals 0. So when I sub in 4 for the x, it's there once, there again, 7 for the y, so it's there again, in both circles. I have to ask myself if left hand side equals right hand side. So in the first case C1 I get 16 plus 49 minus 24 minus 70 plus 29. Is that equal to 0? And that gives me 94 is all the positives and negative 94 is all the negatives, therefore I've shown it's on C1. C2 I got 16 plus 49 minus 8 minus 14 minus 43 equals 0, question mark. All the positives add up to 65, all the negatives add up to 65 also. That gives me 0. So I've shown that 0.47 is the point they both have. Okay, so part D has to find the equation of the common tangent, which requires us to find the slope of the tangent first of all, and then a point on it. Okay, so to find the slope of the tangent, we first find the slope of the radius, because we know that's perpendicular. So the slope of the radius is got by finding the slope between the points 4, 7 and 3, 5. Okay, so I call x1, y1, x2, y2, and that gets us slope of 5 minus 7 over 3 minus 4, which turns out to be 2. Okay, so the perpendicular slope of tangent is, if you change the sign and turn the number upside down, minus half. Now I know that the point 4, 7 is on this tangent because it's the point they both have in common. So that means that I have a point on this line and the slope. Subbing into the y minus y1 line, I have y minus 7 equals minus a half times x minus 4. Multiplying across by 2 to clear the fraction, I get 2y minus 14 is minus x plus 4, which ties up to become x plus 2y minus 18 equals 0.